welcome back. Today we're going to continue our discussion of oligopoly. Remember we said oligopoly is when there are a few big firms where one action by a firm in the oligopoly affects the action of the other firm. They're so big that whatever they do influences each other. So when they're making their profit maximizing decisions, they need to consider one another. Like they literally have to include the other firm's decision process into their profit function. Okay, so last class we stopped with Cournot oligopoly and we asked ourselves if collusion would last, right? We saw that their profit from collusion was better because they were making less stuff, so there was more competition amongst demand, which means they could get higher prices for the stuff, which was great. But we saw that it didn't last because each firm has an incentive to cheat. We also did in-class exercise and in-class exercise, working through that. So what we're gonna do today is just remind ourselves of the steps for the Cournot equilibrium, Cournot oligopoly, before we tackle Stackover, just to refresh our memories on the process. So again, we're in the duopoly model. So we started off by finding the best response function. So basically, in a Cournot duopoly, the goal is to figure out profit maximizing quantity for each firm. And these firms are moving simultaneously. That's very important for us to know because it means that when we're solving for the profit maximizing quantity, we can find the best response function for both firms and then simultaneously solve for their profit maximizing quantities. In other words, no firm knows exactly what the quantity the other firm will do prior to making their decision. Okay, they're making assumptions and finding the optimal point, the point of stability, given all these strategies. Okay. So we need the best response function for each firm. Remember, when we say best response, we're saying that's the quantity that will maximize their profits, right, given whatever the other big firms are doing. Right? Best response means profit maximizing response. So if we're talking profit maximizing, then we're looking at marginal revenue is equal to marginal cost. We're going to do this for firm 1, and we're going to do this for firm 2 as well. But to find marginal revenue, for Q2, and this would be solved for Q1. Okay, so to be able to find these, right, so once you solve for Q1 or Q2, you found the best response function for firm 1 and firm 2, given the options or decisions of the other big firms. To do this though, we need to figure out what marginal revenue is. So far so good? We need marginal revenue, right? Marginal revenue is a derivative of total revenue with respect to quantity. Now, if this is marginal revenue for firm one, then this is the derivative of total revenue for firm one with respect to the quantity produced by firm one. Okay. And to do that, we need to figure out what total revenue is for that firm. Remember that total revenue is equal to price times quantity. If we're looking for total revenue for firm one, then we're looking at price of the market times quantity sold by firm one. Now, it's important to note that our total revenue is in terms of Q. Okay? Which means that our price should be in terms of Q times Q1. Let's talk a little bit about what in terms of Q means. So from the example, we were given a market demand function. Q demanded is equal to, let's make something up, 150 minus, this is demand, so the relationship between price and quantity is going to be negative, 0.4 P. Okay. This is our demand function. It is Q in terms of P. Meaning, we can figure out what Q will be for any level of P. Or, there is P on the right-hand side of this equation, and just P. Okay. If it was Q in terms of P and income, what would that mean? If I was to say this function is a function of demand, quantity demanded, in terms of price and income. What's true about price and income for this equation? Okay, let's do it one at a time. We'll start with you, Trevor, in the back and work down. What does it mean? What do you think it means?
That the quantity demanded in the market isn't only relating to the price, but to the income that the consumers need as well.
Yeah, something with income. Let's say income. So basically, on the right-hand side of our demand function, we have price and income. So, if I say that we need P in terms of Q, this is just for us to understand what it means to have in terms of. So, if we're given this in the question, is typically you're given just your regular demand function. But you need to be able to use that information to find out things for that firm. Find their profit maximizing quantity, or the best response function. Okay, so you're given just this, and we've said we need P in terms of Q, which means that P should be on this side, and Q should be on this side. Does that make sense? So basically, we need to solve for P. Let's do that. If we're to solve for P in this, we 0.4 to the left-hand side of the equal to equation. Or in other words, add 0.4 times p to both sides. And subtract QD from both sides. So we have 0.4 times p is equal to 150 minus QD. We need p by itself, so we're going to divide both sides by 0.4. TJ, I know you just came in, but do you have a calculator? Starting next. So what would this end up being? Just the left-hand side of our equal to sign?
QD.
Nice. Okay, it's equal to? So it's
375 minus QD.
375 minus, Syed, please say it. Omar.
Minus QD? No.
So QD is by itself, but basically it's like 1 times QD, right? So we have 1 over 0.4 times QD. So 1 divided by 0.4. So now, we have our demand function as P in terms of Q. This is what we call our inverse demand function. This is in lowercase q though, so we need to know the quantity produced by each firm as opposed to just the total market quantity. We know that market quantity is equal to the quantity produced by each firm. It's a duopoly, so there are only 2 firms. So we can just expand our Q in here, or replace the Q in there by the 2 Q's produced by the firm. So, if you want P in terms of lowercase q, this would be equal to 375 minus 2.5 times Q1 plus Q2. Right, so P in terms of Q will be equal to lowercase 375 minus 2.5 Q1, negative times positive is a negative, so minus 2.5 Q2. This is the price that we will use in our total revenue calculation. That is market price, but in terms of the quantity produced by firm 1, quantity produced by firm 2. So now that we have total revenue, we can find marginal revenue. Where marginal revenue is the derivative of total revenue with respect to Q. Again, if we're looking for marginal revenue for firm 1, it is total revenue for derivative of total revenue for firm 1 with respect to Q1. I'm showing it this way so you have a thought process to doing your calculation. I could have just said, start here, right? Because basically this is the first step. Once you have price in terms of Q, lowercase q, you can multiply it by your specific Q. In other words, for from 1 or from 2. Take the derivative to find your marginal revenue. What are we doing with marginal revenue next? Why do we care about marginal revenue? Why do we care about marginal revenue? What are we finding in the first place? Oh, who was next? Yes, Jack, what are we finding?
I don't know, but I was next. That's why I raised my hand because I was next, but I don't know.
What do we typically do with margin? Profit maximization, is that what you're gonna say? as well? Yes, best response function, profit maximization. So, your next step will be to set marginal revenue equal to marginal cost. If the question has not given you a number, just a single number for marginal cost, then our next step would be to find marginal cost, which is the derivative of total cost with respect to quantity. If we're looking for it from 1, all of this is based in from 1. If we're looking for this from 2, all of this is based from 2. Note though that in our example, you've been given marginal cost as a number. So for instance, we had like marginal cost is equal to 147, so you don't have to do step 4. It kind of did step 4 for you. Once you have marginal revenue and marginal cost, you can set them equal to one another. Again, we're anchoring these in the firm. We're looking for best response function for each firm, or profit maximizing quantity for each firm. That's our externality condition. Once you have those set together, equal to each other, solve for Q1, solve for Q2. If there's symmetry, as in they have the same cost function and production, identical products, then once you have Q1, you know you can just switch the Q's because they're symmetric. Maybe I should make this step 6. Step 6 gives us each firm's best response function. Once we have our best response function, the next step is to find equilibrium, because we're still looking for the actual quantity that maximizes their profits in a world where they're moving simultaneously. So we need to find a point of stability where both firms are best responding to each other and maximizing their profits. So next is to find equilibrium. For equilibrium, we have our two best response functions. So, and we're solving simultaneously, so we're just going to plug either Q1 or Q2, but let's stick with Q2. into Q1. What does that mean? Well, if we had that Q2 is equal to 0.5 plus 2 Q1, and by symmetry, again, I'm making this up, by symmetry, Q1 would be equal to 0.5 plus 2 Q2. If we're using these two batch response functions to solve for their equilibrium or profit maximizing quantities, we can substitute what we know Q2 is into Q1's batch response function. Right? Where Q1 will then be equal to 0.5 plus 2 times this entire thing. 0.5 plus 2 times Q1. So in this, at this point in step 1 of equilibrium, we would have one equal to sign and one unknown. We can solve for Q1. Which leads us to our step 2, which is to solve for Q1, and that will be Q1 star, profit maximizing Q1. Next step is, once we have that Q1, we plug Q1 star into Q2 to find Q2 star, which is the 4. Solve for Q2 star. So we need equilibrium, price, and quantity. This gives us our quantity. The next step is to find price. So we get the market quantity as Q1 star plus Q2 star. Next, we plug AQ star, market equilibrium quantity, into our market price function. Now, you could go this way with step 5 and 6, where you sum your quantity together and then use your big market demand function to find price. Or you could just plug each of the individual Q's into your smaller P. Either way, you will get market price. Which is step 7. Solve for E star. The last one I will talk about is collusion, and then we'll start working on Stackelberg. The next obvious thing is to say, well, we see that there are two of us in this market are competing with each other. It's actually hurting our profits, which I didn't write about, but we know how to find profit, right? Profit is P minus ATC times Q. If we go from 1. So let's collude. Let's collude, increase our market power, increase the price of the market, get higher profits. If that's the case, they're acting as a monopoly. So our steps would be, 1, again, we need total revenue so that we can find marginal revenue. This would be equal to P in terms of Q times Q. Notice that we're using the uppercase Q here because this is market quantity. They're acting as 1. Next would be to find marginal revenue, which again is a derivative of total revenue with respect to big Q. 3 is to set marginal revenue equals marginal cost. This is especially true if you're already given marginal cost as a number, like they just solved step 4 for you already. 4. So for U star M. M there stands for monopoly, also markets. 5 will be to plugins or QM star into our price function so we can figure out what market price equilibrium will be, which leads us to step 6, which is to solve for P star. 7, profit for each firm will be equal to big Q divided by 2 because they're just going to split the quantity evenly between each other, times P minus ATC. So profit for firm 1 will be equal, should be equal to profit. Now, this that I just wrote for you, all these steps, was curated by an old student of mine, one of the first iterations of this class that I taught. So what she did was she went through the steps, the calculations in class and at home by herself, and came up with these steps on how to solve for them. Hopefully they're helpful for you. That was brilliant, so I'm sharing it. Okay. Let's move on to Stackelberg. 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 Oligopoly model. Named after Stackelberg because he solved this first. There's some things that are extremely important about the Stackelberg model that help us differentiate between Stackelberg oligopoly and Cornell oligopoly. The key thing though is that with Stackelberg, there is a leader and this is duopoly. There is a follower. We're going to solve this for duopoly because it's the easiest version of our solution. So in this market, there is a first mover, the person who figures out the technology first, who gets the contracts first in that market. They're the leader. Once they have it, people see what they do, other firms see what they do, and follow them into this market. Now, what Stackelberg showed is that if a firm can get to the market first, they can increase their profits without needing to collude with others. Basically, it is a legal way of extracting as much profit from the market ethically. Just innovate faster. Which is why a lot of the big tech firms are investing so much money in AI. Because the first firm to crack it and properly crack it will be the leader in this market, and they will take a lion's share of the profit in the market, and everyone else, all the followers, have to scramble for whatever is left. So let's do the calculation and see what that looks like. So something to note is that unlike Cornell, where they choose, they being the firms, choose Q, the quantity they're going to produce simultaneously. Stackelberg's model has a sequential order to, or order of choosing, Q. So the leader chooses their quantity first, and then the follower is stuck in whatever option or reality the leader chooses. If you're in game theory right now, anyone in game theory right now? Okay. This would be your game tree example scenario where you'll be solving for the subgame perfect Nash equilibrium. In other words, what ends up happening is that the leader knows that the follower will be stuck best responding to their choice. So what they do is they incorporate double O, cooperate, or single O? Single, right? Thank you. Incorporate, or include directly into their profit maximizing condition. In other words, into the total revenue function, the best response function, of the follower. So what they're doing by doing that is I'll continue on this side. The leader predicts what the follower will do before the follower acts. Then sets output level, sets an output level that maximizes their profit at the follower's expense. So, what the leader does is, the leader is the first mover. Sure. Leader is the first mover in this scenario. So what they're going to do is, first of all, they will calculate the best response function for the follower. Then input that best response function into their profit max calculation. Let's do it. We're going to stick with the example we've been working with Cornell, except now, as opposed to these two firms acting simultaneously, one of the firms, and we're going to assume that that's American Airlines, is the leader in this market. They're the first mover. Equilibrium example. When you hear the term Stackelberg, think leader and follower, sequential. Cornell, simultaneous move, normal form game. So just the matrix. Stackenberg, game tree. Okay. So we had that the market demand, or market, is equal to 339 minus P. Marginal cost, the question told us is 147, which is also equal to average cost. So they've done step 4 for us, which is great. And now it also says that American Airlines is the leader or first mover, and United Airlines is the follower. They are stuck with whatever reality American chooses. Visual learner and a visual teacher. So as I say this, I'm building a tree in my mind. I'm contemplating building a tree for you as well here. Please just focus on what we're trying to visualize, not necessarily on where the tree came from, okay? We're making this up for ourselves. So we said American Airlines was a leader, right? They are going to choose either, they have 3 options, for instance, to produce low quantity, to produce medium quantity, or to produce high quantity, whatever those numbers are. So 1 fleet, 2 fleets, 3 fleets. Now, once American Airlines makes this decision, United is stuck in that reality. So United Airlines can either be in this reality, where American has chosen to have only 1 fleet in that market, or they could be stuck in this reality where American has chosen to have 2 fleets, okay? Or they could be stuck in this reality where American has chosen to have 3 fleets. Good so far? Now, United also has decisions to make. So if United is stuck in this reality of the 1 fleet, it can decide to also do low, or medium, or high output. Same, if American chooses medium, United can choose in this reality, we should use different colors, to produce low, medium, or high. Same, if American chooses the 3 fleets, now United can respond to that choice by either producing low, medium, or high. What happens is, by calculating that best response function for United, American is able to figure out what choice by calculating the best response function for United Airlines first. American Airlines is able to figure out the best option or strategy for themselves, given how United Airlines will respond to your choice. If this was a game theory class, I would proceed to give you the payout options in each of these scenarios, and then work backwards. You would say, well, if this was a scenario, and first mover, bear with me here. I really want you to understand this. Game theory is my favorite topic. Bear with me. Okay. So American Airlines is first mover, their payoff is first, so if they choose low and United chooses low, they will get 10 million. If they choose low and United chooses middle, they will get 11 million. If If they choose low and United chooses high, they'll get 12 million. They will get 12 million. We can figure this out as well for United. Now that they're stuck in this reality of American choosing low, their payoffs are either 5, 2, United is blue. So given this reality, which of the production outputs will United choose? 5, right? Whatever gives them the highest payoff. Does that make sense? Is this good for American though? No. American will be stuck with 10 instead of the high 12. So American will choose not to go with the low fleet because they know that if they do, United is going to choose low. Yes, low. Does that make sense?
Is there another? I feel like I've learned this, but in a different like.
Backward induction, game theory,
Yeah.
subgame, perfect.
Oh yeah, game theory. Yeah.
Subgame, perfect matching conversion. So we're going to do the type of analysis, but with our equations here. What we solve, the best response functions we calculate, will actually help you in game theory to figure out the payoffs in each of these scenarios. We're not going to go that deep into it. We're just going to find the final equilibrium, the point of stability for both firms. Okay. Imagine if I change these numbers up to be 2, 3, 5. Which option will United choose? Yeah, 5. Is this good for American? So will they stick with low? Right? Because if they choose low, United is going to choose high, which will give American the highest payoff. So we would say this is our subgame perfect matching equilibrium. What we want to find is which of these combinations is true for United, for American and United, given this equation and their cost functions. And the fact that American airline is moving first. Okay, let's do it. Don't worry, I'll talk you through our steps. I just want you to understand what we're trying to find. This is not something I'm going to test you on either. Again, I just want you to build to understanding as we go through the calculations. The calculations I will test you on. You should be able to do that by the end of this class. Okay, so from this, you see that American Airlines is the leader, which means we need the best response function for United Airlines first. American needs to figure out which of these output levels United will pick in every single scenario, because that's what a best response gives you. Your best response in every single scenario. So let's do that. We know how to find the best response function. We literally just went over it. So we're going to do it together now. It should be refreshingly similar to what you know. To find the best response function for United Airlines, we need, basically we're going to solve for QU, right? So we need the total revenue, we need to set marginal revenue for United Airlines equal to marginal cost for United Airlines. Switching to that. Marginal revenue is a derivative of total revenue with respect to quantity, so we need P times Q. We need P in the market times Q for United, so we can get our total revenue. remember, we're going to use this to find P in terms of Q. If we were solving for P from that, where Q is equal to 339 minus P, solve for P means that we're going to have P is equal to 339 minus Q. We don't have to divide through by anything, or we're dividing through by 1, which is the exact same thing. But we want this in lowercase q, so this is 339 minus Q1 minus Q2. So we have 339 minus Q1, not Q1, QU minus QA. Times QU. What is, can you wake my TV up, please? It's not okay. Okay, so why are we using United as our Q here? Who's next? Rico, are you next? Why are we using United as our Q here?
Trying to find the best response, right?
For who?
QU.
Nice, for United. Awesome. Okay, so let's go ahead and solve this through. Again, this is total revenue for United. This is 339 times QU minus QU squared minus QA QU. Total revenue for United, so we can find marginal revenue for United. The derivative of this function minus QU squared minus QA QU with respect to what? We don't know your name. Tell me your name?
Oh, Sterling.
Sterling, okay. With respect to what?
D.
Yeah, D's derivative with respect to what? Which of the Q's are we going to use here?
Oh, QU.
Which is what? Cam.
You have just a numerator?
So the derivative of the total revenue with respect to QU is equal to what?
339 minus 2Q.
339 minus 2QU. Nice.
Over Q. For QU.
Minus QA.
Or minus QA.
Okay. Once we have that, MRU is going to be set equal to MCU, which in our case is just 147. So we have 339 minus 2QU minus QA is equal to 147. Solve for what, Jiva? Very nice, we're solving for QU because we're looking for the best response function for United. Okay, so we have 339 minus 147 minus QA is equal to 2 times QU. Trying to get QU by itself. 339 minus 147 is 192 minus QA is equal to 2 times QU. Divide both sides by 2. We have 96 minus 0.5 QA is equal to QU. You should recognize this from our Cornell calculation because this was the exact best response function from Cornell. So if this was an exam question and steps 1 through 6 said Cornell, and step 7 was like do this for Stackelberg, you don't have to go through this entire process again because you already have the best response functions for each term, assuming that we're moving simultaneously. So you just take that for whoever your follower is. In this case, United. This is the best response function for the follower of United Airlines. This is where Stackelberg gets interesting because our next step is typically find best response function for the other firm. With Cornell, we're like, oh, symmetry, we just changed the views. But we're not going to do that here. We're actually going to go ahead and solve it through for our leader because it's not exactly the same. So now we need MR for our leader, American Airline, equal to MC for our leader, American Airline. To do that, this is the derivative of the total revenue for American Airlines with respect to Q for American Airlines. Our total revenue is equal to P in terms of Q times QA. We know P is 339 minus QU minus QA. Instead of continuing here and assuming some general level of production for QU, American is going to plug in the best response function for United Airlines directly into the total response or price function. P. Total revenue equation. Specifically the P part of total revenue. So this is P times QA. So total revenue for American will be equal to 339 minus 96 minus 0.5 QA minus QA times QA. Doing this, they directly fix the choice options, the choice structure for United. In other words, they're saying, well, we know the possible responses for our follower in whatever option we pick. So let's tie their best response directly into calculating or figuring out which of these levels we should choose. That way, they're able to tell how the follower will respond or choose. Let's continue our calculation here. This will be equal to 339 minus 96. Negative times negative is a positive, so plus 0.5 QA minus QA times QA. Total revenue for American. 339 minus 96. What is 339 minus 96? What is 339 minus 96? 24 what? 243 Q plus, well, we have plus 0.5 QA minus QA, so it's like 0.5 minus 1, which is negative 0.5. So this will be minus 0.5 QA.
Wait, so why would it not be a positive 0.5? Because wouldn't they just cancel
Which ones?
the QAs?
So
0.5.
this is-
Oh.
You owe the whole QA, but you only were
Yeah, but
receiving
it's a
half of
1
it
in front
back.
of the QA. Yep. Okay.
Yeah. So you
Thank
still owe that half.
Yep.
Okay. Total revenue for American Airlines. So we can expand this. This is 243 times QA minus 0.5 QA squared. Total revenue for American Airlines. That point in our discussion where we were like, okay, which option is United going to pick? Well, obviously they'll take the highest profit. is what we just did in that equation. So that American can figure out which options United is going to pick in every single scenario. Okay. Marginal revenue for American would equal to the derivative of total revenue for American with respect to your next guy. Next, with respect to QA, the quantity for A. So this is equal to 243 QA minus 0.5 QA squared. Derivative of this with respect to QA. Stand.
Wouldn't that just be 243 QA?
But that goes to 0.
So just 243.
Sorry, that was 1. That was 1. Going to the raised bar of 0. Everything raised bar of 0 is 1. That was 1.
Minus 2 is in the front because you bring it over times 8.5
Okay, which is equal to 243 minus. Jonathan, what is 2 times 0.5? 1. Just times minus QA. This is our marginal revenue for American. With this, we can set them equal, set X equal to marginal cost. So we have 243 minus QA is equal to 147. The question gave that information to us. So 243 minus 147 is equal to QA, which is our start. What is that? See. $86? 96. So in fact, the way the information was set up, if we had filled that in with the chaos, this tree with the chaos, we would have seen that United will choose whatever they choose down here, and because of their choice, this scenario of producing high would be the profit maximizing, the highest profit option for American. Okay, so now that we know QA star, we can find QU star. What function do we use to find the profit maximizing quantity for the firms? Oh yes, absolutely. That's the optimality condition. But what function do we apply this optimality condition in? We're calling it, we've been saying it over and over. Best response, right? So we're going to use United's best response function to figure out the quantity that will maximize United's profit. United's best response function is 96 minus 0.5 times. For us to get star, we have to plug 96 in here for QA. Sarish, what is this equal to?
So it'd be 96 minus 48. Which is 48.
So, what we're saying here is that on that last line of our tree, United was maximizing its profit when it produced low of 48,000 seats. And that was the highest profit that American could make in all the possible scenarios that it had. We have calculated that though, without needing to go through a tree. We calculated that using the demand function in the equation for the market and the marginal cost function. Okay. Now let's see the profit at each of these levels for both firms. for American Airlines would be equal to, right, P minus ATC times Q produced by American Airlines, which for us is, what's the price, do we know? Not yet, right? Q is equal to 339 minus Q, which is 339 minus 96 plus 48. That's the total amount of quantity in the markets in Bolivia. Jenny, what is that? 195. P in the market. P star. So the price in the market for each seat is $195 minus our average total cost, which was question do you guys? Give that to us. 147 times the quantity produced by American. Can you calculate that for us, please? Thank you, Marisa. So profit for, while Hamza calculates that, we can figure out profit for United Airlines. This would be 195 minus 147 times the quantity produced by United, which is 48. Nicole, can you calculate that for us, please? United Airlines. Do you have it?
Yeah, it's
4,608
Yeah.
is a profit cleared by American Airlines. What is the profit cleared by United in this scenario? 2,304. 2,304. For one firm to be able to get this type of profit differentiation from the other firms in the market, they had to cheat in a collusion, right? They have to form a collusion and then cheat in that collusion. But with Stackelberg, or with being a first mover, you can get that kind of profit without having to go into a collusion agreement and then cheating on that collusion agreement. Let's compare this to Cornell. So Cornell versus Stackelberg. Their quantity made by American, the quantity made by United, the quantity in the market, price in the market. Profit made by American, profit made by United. Here we had 64, so like the medium, two fleets. Total market quantity was 128, which made price 211, not so great for consumers. Profit for American was 4,096. Profit for United was also 4,096. The Stackelberg, American, the first mover, made Q of 96. United, the follower, made Q of 48. Total produced in the markets was 144. Better, more seats.
For the profit of UA, why is it like in a reverse American as well?
Say it again.
Like the profit of UA and AA are the same, even though it's gonna be the same?
Oh, that's a good question. This is Cornell, and in Cornell we had symmetry. That's why they're the exact same. That's why they're also producing the same quantity. Symmetry is in they have the same cost function, and they're making identical product. Price in the market was 195, also good for consumers. The first mover had a profit of 4,608, great for the first mover. The second mover, or the follower, had a profit of 2,304, not so great for them. Right? So in a Stackelberg scenario, where there is this competition to get to the market first, it's great for consumers because it's innovative, right? And it leads to more quantity being available in the market, thus lower price paid by the consumers. It's great for whoever gets there first, but it's quite bad for whoever is following. However, we should note that whoever is following is probably not investing as much in their R&D to be the first. That's what you would hope. But overall, this adds up for the market. Any questions about this? Next class, you're going to do this by yourself. Second class is exercise, extra credit for your final. So make sure you show up. We're also going to talk about Bertrand and one of those